Hi, I am Ambrose Chan, and today I would like to share my research on sea urchin feeding behaviors and its impact on kelp forest conservation. Kelp forests are extremely ecologically valuable marine ecosystems, the tropical rainforests of the ocean. Beyond providing a critical habitat and supporting biodiversity, kelp forests play a significant role in carbon sequestration, fixing millions of tons of carbon dioxide annually. They also improve water quality by regulating nutrients and serve as natural coastal barriers. However, kelp forests have been facing a severe degradation, in some areas declining by over 90%. Main drivers include overgrazing by sea urchins, climate change, ocean warming, and overfishing. The explosive growth of sea urchin populations is particularly concerning. They can completely destroy kelp, resulting in urchin barrens. Experiment 1. To investigate whether group size influences the feeding behavior of sea urchins, we established experimental groups with different densities, single, 5, and 10 urchins. Results showed that, compared to a solitary urchin, the average individual feeding rate within the group increased significantly, indicating that group living may enhance feeding activity. Experiment 2. We further investigated the feeding preference of sea urchins for live kelp versus drift kelp. Results indicated that sea urchins exhibited a preference of the kelp type when it is dominant, while preferring the live kelp in equal supply. This flexible foraging strategy results in a feedback cycle, where grazing on live kelp can lead to front detachment, generating drift kelp that sustains sea urchin populations. Experiment 3. To study the influence of predators on sea urchin feeding, we introduced a natural predator of sea urchins. Results showed that even without direct attack, the presence of the predator reduced the total feeding amount of sea urchins by over 60%. This indicates that chemical cues released by predators can effectively suppress sea urchin feeding behavior. So, what about the key findings and conservation measures? This project demonstrates that sea urchin feeding behavior is commodulated by group density, food type, and predation risk. Therefore, targeted culling should be implemented to break up dense urchin clusters, rather than removing solitary urchins. Secondly, drift kelp needs to be removed to disrupt its cycle, leading to urchin barren. Finally, protecting and restoring populations of sea urchin predators is key to maintaining long-term ecological balance. Thank you for listening.